Our time today as well as the chat. This session will be recorded for future use, and it's my pleasure to introduce Dr. Rusty Leonard and Dr. Mohamed Abusharkh for their presentation, Building the Autonomous Vehicles Program at Ferris.
Thank you, Michelle. Good morning, everybody. Great to see everyone. Today we'll talk about establishing the Autonomous Vehicle Graduate Program at Ferris. And this is a research project supported by the Ferris Innovation Grant. Mohamed Abusharkh here, and Dr. Rusty Leonard, and Jacob Goldell, who's a senior student at the Digital Media Software Engineering Program. Today, we'll discuss the challenges to start the graduate program in the area of autonomous vehicles as of today, 2021. We'll demo the progress for 2 or 3 ideas that might represent a promising starting point for us at Ferris. First, we'll talk about the significance of the autonomous vehicle area, and I'll leave it in Dr. Leonard's hands.
Thank you. As you can see from this slide, autonomous vehicles are quite a significant slice of what is coming up. We also know that electric vehicles are being promised to us by a lot of manufacturers, and a number of countries are claiming to go to a more carbon neutral transportation system. And so, focusing in on AVs, you can see there's a lot of money that's being spent, a lot of development work going on. There's a lot of interaction, as you can see from this graphic here, between automotive companies and technology firms. And this really is the basis for the idea of combining software engineering with automotive and with information security to kind of replicate this at Ferris and create our own center of excellence. Next slide. Thank you. What's really interesting I've learned a lot putting this together, and I love sharing this with everybody so that you can be better too. In the PCAF that I put together, I was asked to provide a real good rationale as to why we would want to do this. And what I ended up doing was I reached out to Steve Reifert's team and found out that Jennifer Hagenauer has access to software that allows her to do job posting analytics. And I just want to spend a moment here because this is kind of a neat thing. She searched on the following keywords: autonomous vehicle or connected vehicle or electric vehicle or advanced vehicle in Michigan, right? And so the data showed that there was 83,351 total jobs between July 2017 and December 2020. And of those, there were 12,343 that were unique to our keywords, right? And so these numbers showed a posting intensity of 7-to-1. And that means that for every 7 postings, there's 1 unique job posting with our search keywords in there. And that is higher than the posting intensity for all the other occupations and companies in the region. That's 4-to-1, right? So that indicates from Jennifer's analysis that companies are trying harder to hire folks for these type of positions. And what's really interesting is that the median advertised salary was $97,700, and that makes a statement there. So these are jobs that are in Michigan. So our students, coming to Ferris will be able to, stay in state and advance our state. And this is just a super opportunity to really do this, and it's really needed. So what we did what our really background plan was to create this degree was to take the software engineering side, which leans itself more into the autonomous vehicles and the coding and stuff that's involved, and then the automotive side with the electric vehicles and the other technology that we would bring to the party, and also the information security with the connected vehicle security. So there's 3 pieces to the puzzle that we bring together, and we create this smart vehicular technologies master's degree. And so what we ended up doing is we took certificates from ISI and software engineering, and we're creating a certificate in automotive and putting them together with a capstone. And in a nutshell, that's going to be our master's degree.
Thank you, Rusty. Moving on to the fun part, right? That the challenges to start all of this. Just to talk a little bit about the degree as well and our project. What are we trying to resolve here? First, the technology on the field is really still maturing. It's not ready. There's no standard technology to use. There's no really winning technology, if you will. Companies are still competing. So you kind of want to start this while still kind of it's still of a moving target of such. So another thing that you want to kind of be wary of while you're starting and investing in infrastructure and all of that is you don't want to be tightly coupled or locked in with one vendor. You want to go for a certain direction with autonomous vehicle, but you don't want to use a technology that I have to stay with Toyota for all the time, or on the software side I have to stay with Google all the time, etc. And then there's the challenge with students as well. Like as you've seen, these are different areas. You have different, undergraduate students coming in. If this is a master's degree, you want a student who has a software background, who has an automotive background, a little bit of machine learning, a little bit of connection, networking, security. So you want to build a degree in a way that makes the barrier to entry, if someone is not from the exact area, to kind of get into that area in maybe a course worth of effort or a little bit less if possible. And then, of course, the usual high standards that we try to achieve in terms of creative learning methodology, getting students engaged. This is a highly technical area, so you want it to be possible to start and kind of more exciting, if you will. Good news here is the opportunity window is still there. It hasn't closed yet. And, the whole state, you can look around. There is no strong, dedicated autonomous vehicle program. At least with the universities that we're usually competing with. We're not going to look at U of M, but the rest of the state universities, they're still starting and finding their way around that area. So what do one important concept here is, what is it really that we need to learn? What is it? You're a student, you want to kind of, let's say, master the skills to build an autonomous vehicle. What is it that you need to learn? And that will really lead the way to what is it that we need to teach as a university. So these are the different areas or different focuses. So first, you want to be really, this is mostly making the car think, or moving the car from control by a human to control by a machine. So obviously the high focus at the beginning is machine learning. You need to have some programming skill, not necessarily super advanced 4 or 5 years or anything, but there is programming involved definitely. Predictive machine learning, the car has to start, thinking about making a decision. When do you detect an object? What is it seeing? Is it seeing the lines on the road? Again, making traffic predictions and all of that is highly based in machine learning, specifically an area that is called deep learning, which is gaining a lot of attention the last 5 or 6 years. There's also tracking objects. That's a bit of a challenge for the car. So not recognizing a traffic signal, recognizing the cars in front of it when they're changing speed in the snow or in difficult weather condition. This is all, again, in the object detection and tracking module within the vehicle's computer. There's also localization, which is basically how the vehicle decides where it is in the world at a certain moment. The standard, I would say classic technology is GPS, but for autonomous vehicles, GPS accuracy is just not enough. You have to have accuracy within the location, within a few inches at most, so you'll have the efficiency required to drive and be safe. There's also the work on path planning. So the car or the vehicle is moving, trying to predict traffic, trying to plan the path from point A to point Z. All of that is done also and we need to program it as well or build it within an autonomous vehicle. And then finally, putting all of that together and building that, if you will, vehicle computer that makes these decisions on the fly. It's a bit of a complex control system that takes in all the sensory input that comes into the vehicle and then processes all of that and makes the right decision with minimal risk in milliseconds or even less than that. So that's mainly what we're trying to achieve, and this is a set of skills that the student would have to have mastering of the autonomous vehicles. So how do we start? You might have seen also in the previous slide, autonomous vehicles are highly a software endeavor. There's a lot of software models involved, complex and connected ones. Sensors have been there for some time. They're still developing, but the magic really, in my humble opinion, is in the vehicle's computer. So how do we get students to gradually learn this multi-level, multidisciplinary concept? And the ideas we're offering in this project are really using a three-level approach. We start with Deep Racer, Amazon Deep Racer. It's a small product, small car, 1/16 size, but it's fully autonomous. Typically, these cars, they train on tracks, and we'll see them in action. So I'm not gonna, talk about them too much, but really, they're fully autonomous. They have the sensors. Students can really get a good starting point in a contained environment and train on that one. You program it, you control it, and then it goes on the track. The next level is a fully detailed software simulator that research companies use. It's called Carla. It's open source, and it gives you all types of controls over the scenario where you want to train your car, if you will, or control what it sees, weather conditions, traffic, etc. Once the student kind of tries all of that, we use that to learn the main concepts of really what we've covered until now. Then we move on to the third phase, which is a device called Open Pilot. This device has open source software, and it gives autonomy to vehicles of all types. Like there's 70 or 80 vehicles that are on the website as of now, and it's a small device you put in, and it's running right now. The device itself is around $1,000, but the software, which is the most important here, is open source. So we can use that to test, evaluate, and run that on an autonomous vehicle. I'm gonna move the presentation to Jacob, our senior student, who's really done a great job working on both Deep Racer and Carla. We'll demo where we are with these things, and then we'll come back to discuss the demo. Thank you. Jacob?
Yep. Let me share my screen. Are we all good? All right, so I'm going to start by demoing Deep Racer. So while this is a physical like RC car you can drive around, to start, you actually want to start in a simulation. So this is provided by AWS. It like runs on the web, so you don't have to worry about running it yourself pretty much. But yep, you can just play this. So essentially what's happening here, this is a simulation of the environment. So the Deep Racer car has a camera on the front of it that it's grabbing as input. And based on that, it's making decisions whether it should turn left or right or just go straight. As a programmer, I'm providing it with like rewards. So what's happening, say in this example, is it's getting a bigger reward for staying in the middle and a negative reward for going off the track. So over time, it learns to maximize this reward that I'm giving it, which means it wants to stay on the track as much as possible. So it learns from that, from the camera input that it's given, whether it should turn left or right or straight. So what you're seeing here is a model, a machine learning like program that I've trained that has learned to stay within the track. You can see it going around. So we won't watch all that, it's pretty much the same. But from here, you want to take it into the real world, physical. So first I'm going to show you a bit of the controls and what this looks like. So the camera down here is just me recording it, so you can get an idea of what it looks like when I'm messing around with this. But this window you see back here is just on my laptop. I recorded it. So from here, you can load what I talked about, the models, the actual program that's able to drive it. You can load up right here and tell it to start. But if you want, you can also drive it around manually, which I will show. So it gives you a little joystick, and it sort of just controls, like I said, like an RC car. So you can move it around, try and drive it around the track yourself if you want, but the main goal obviously is to get it to drive itself. So first, I needed to create a track which mimics the one in the training environment. So you can see that here. This
is Jacob's garage. I mean, we it's
Yeah.
virtual law. So this is at home. You had to
Yep.
take out the cars from there.
Yeah. It was a bit of a pain setting this up every time because like you can kind of see it's in rolls. So like it's sort of like a flexible like roofing material called asphalt felt. So you just like roll it up after you're done with it. And yeah, so it's quite the process. But what you can see here, this is the camera that it's seeing as input and basing its decisions off of. And then what you're gonna see is a model that I loaded up. So this is completely autonomous, what you're about to see. So. See, it takes corners pretty well. Now it isn't perfect. As you can see, it just went off the track. So there's still work to do and improvements to make. As of right now, I'm pretty happy with it because it is actually, you know, taking corners like this, which is really weird to see. Yep, it goes off again. Hey, it did a lap. So from here, we're going to move on to Carla. So I was work with Deep Racer. Now we're going to get into Carla.
So Carla is really more of the industrial simulator for testing these algorithms that work on real cars. It has all types of different sensor packages, realistic, that really have the accuracy of the real sensor. It has, as you can see, all types of weather scenarios. You can design the traffic, which city, all of that. So it's really a great learning environment for kind of taking this a little bit deeper. It's an open source simulator. It's built on Unreal Engine, a gaming engine, which, you know, we have experience with at the School of Digital Media as well. So we can, you know, there's potential for making our own or editing it or doing all that type of stuff. Diverse weather, lighting condition, and the effect of that on the vehicle itself. So it has huge potential for teaching all types of scenarios. And this is the experimental environment that you want to kind of have most classes in. Let students master the concepts and then move on to actually testing on a real car. So I'm going to let Jacob show us what we did with that environment until now.
Yep. So to start with, compared to Deep Racer, there's a lot of challenges when it comes to working with Carla. The big one is Deep Racer has pretty much everything set up for you, and it's just up to you to decide how you want to reward the car and train it. But in this case, you have to actually create that environment yourself. So you have to decide like, oh, what sensors do I want? Where do I want to put them? You know, everything like weather, roads, what maps, stuff like that. That's all up to you. So it can be a bit overwhelming, and there's a lot of code to start out with, which I will show here. Tons of coding later. I had to learn a whole bunch of new skills when it comes to programming. And in total, it ended up being like 600 lines of code to actually create the first working environment to train the car. So it was quite the process. But what I ended up with was a training environment where there's just one car. It has a camera on the hood that sees in black and white, just to keep it simple. I can go left, right, straight. For the rewards, it gets just a positive reward for continuing on and staying alive, a negative reward whenever it crosses a road line. So you can see sort of like in the image right now, there's this underline. So it would get a negative reward for crossing that. And then also a negative reward for running into something. And whenever that happens, it goes and resets it back on the road, looking straight. So
just like puppy training, you know?
Yes.
Just
so here,
much more slower.
Oh. Yep. So this is the actual, what I see from Carla in the environment. The top right here is the actual script I created running. So this is with no training. So at this point, it's basically just trying random actions to see what will happen, what it should do and shouldn't do. So you can see it just goes around, runs into things. It's not that great. Don't think I would trust this on the road. From here, though, After you give it, this was around 2 hours of training, it starts to show some signs of learning. So it basically just goes straight all the time because it learned, okay, generally when I turn, I'm going to go and hit something like a light post or a wall. So if I just go straight, like that'll be the best thing for me right now. So as you can see, not perfect, just run straight into a wall still if there's something in its way at the end. But this is an improvement over randomly turning all over the place. So it's a good in between. From here, giving it more time, around 10 hours of training. I just let it run overnight. It really now starts to show some signs of learning when it shouldn't do different things. So while still not perfect, you can see here it's angled in and it's going to cross the road line. If you remember that, that'll give it a negative reward. So it wants to try to avoid that. In this case, it doesn't always do the right thing. Usually it just ends up kind of spinning out, as you'll see. But the fact that it is trying to do something different other than going straight is a pretty good improvement, I would say. You can see it just turns, it goes the wrong way, but it knows, oh, I'm crossing a line right now, I need to do something different. If you remember
Jacob,
here, yes.
just as a time check, we're about 1 minute over.
Oh, okay. I'm pretty much done. So as you can see, it just turns and tries to avoid things. And as of right now, that's as far as I've gotten. So, you know, there are improvements to make, but as of right now, that's where we are with the project.
Thank you, Jacob. I appreciate that. Well, I mean, it's the questions time. I don't want to take any of that, but this is our plan. Our next step is working on Open Pilot, the open source, you know, really package and connecting that to a car. You know, what our next grant request will be for a real car to test Open Pilot on, but that's for another day. We're here to answer any questions. Please feel free.
Okay, so far we have a couple of comments from Glenn. Very interesting. Thank you for your work and presentation. And from Nikki, although Carla is more time consuming, the learning is invaluable. And from Laura, excellent job, Jacob. Very proud of you.
Okay.
Oh, there's another one from Nikki. Awesome work, Jacob. As a former engineer, this is interesting and great work.
Thank you guys for those comments. That's nice.
Okay. Great. Thank you very much for being here. That's our presentation. Have a great day.
Okay, there is one question from Glenn. How much time training in Carla to date?
So like I said, with that last model, it's probably around 10 hours just for that. But of all of the different models that I've tried and tested and reward functions and stuff, I mean, at this point, it's probably like 50 or something. Like, it's been a lot of hours in Carla.
That takes us to like that hours of training for the model to get to that advanced level depend on the processor we're running. If we have a regular NVIDIA gaming processor that's in a PC, that takes this much time. If we have a better processor, a more parallel computing kind of processor, we can, without getting into too much detail, it can be compressed, and that's what when you have an industrial level machine learning models, that's what they do. We have other processors to work with, and this is something we want to explore. We're at the proof of concept stage right now, so we hopefully want to explore. Once we have that, we can explore this a little bit more. Maybe I don't know. I just want to note here that Jacob has worked really hard on this. Excellent work. This is graduate level research work, and this is just 2 or 3 months of work. I mean, and weekly, and within fitting all of that within the courses. So I appreciate his contributions.
There's a comment from John Maroney. I have had a few industrial design students design user experience around autonomous vehicle ideas. Let's collaborate at some point.
Of course, that would be great.
So we've got about 1 minute left if there are any more questions. Otherwise, thank you, Dr. Leonard, Dr. Abusharkh, and Jacob.
Thanks a lot.